Unit so far, real quick. If we have a central angle that starts from the center of the circle and works its way out, isn't a central angle equal to the arc?
Yes.
So this is 60 degrees, what's the central angle?
60 degrees.
And if the central angle is 120 degrees, what's the arc? 120. Then we learned to find the physical length of an arc. Instead of just the measure of the arc, the physical distance. It's radius times theta, where theta would be in radians, right? So we take it in degrees, change it to radians, so it's a physical distance, then times by the radius. Radius times theta, correct? Then we learned how to find the area of a full circle. It's pi r squared. I'll fill it all in. Circumference is 2 pi r. Circumference is the physical distance of the full outside, right? Then also, we learned how to find area of a section of a circle. Instead of filling in the full circle, just a section of the circle. So it's the section over the full circle. So a section out of 360 pi r squared. Similar to pi r squared full circle, right? And then we learned last time, if you have a tangent line touches the circle in exactly one spot. If you have a tangent line, then you have a point of tangency, and if you drop a radius to the point of tangency, it's a 90-degree angle. That's what we learned yesterday, right? Okay, getting to right away to what we're learning today. So 8-5, inscribed angles. So an inscribed angle is different than a central angle. An inscribed angle is an angle formed by two chords on the circle, starting not at the center. So before you write down any of this, we just need to understand what a inscribed angle is. So once again, an angle formed by two chords. So you don't need to necessarily write that down yet. Everybody just look up here so we understand what an inscribed angle is. Do you see chord AC? At chord A, chord CD. Do you see the two chords? They're forming an angle. And that's called an inscribed angle. So an inscribed angle starts on the outside of the circle and works its way out. So do you see how this is an inscribed angle and it opens up on arc AB? Yes? Okay, awesome. Okay, so if you have an inscribed angle, then the rule is that angle, theta, will be half of its intercepted arc. So once again, an inscribed angle is half of its intercepted arc. So let's put that into context. If this arc is 60 degrees, then this will be half that amount. Therefore, my inscribed angle would be 30, because that's half of it. Does that make sense, everybody? An inscribed angle is half of the amount of its intercepted arc. So let's think about it. Let's go backwards. So if this is 30 degrees, and if we know this is 30 degrees, couldn't we take 30 degrees times 2 to get this arc? Yes, right? Now, here's the algebra. Because if theta is equal to 1/2 of arc AB, couldn't we multiply both sides by 2? Yeah? Right? So that'd be 2 theta, 2 to divide out arc AB. Does everybody understand? So you have to be able to go both ways. An inscribed angle is half of the amount of its arc, or this angle times 2 is equal to this arc. You guys understand it both ways. So if I said, because first hour couldn't grasp that, if this is 40 degrees, what's this arc?
40.
80, right? 2 times the angle would be the arc, right? You wouldn't say the angle's equal to the arc, that's a central angle, right? Is everybody good with that? So one more time, if this is 100 degrees, what's the arc? 200 degrees. So let's go backwards. If the arc is 300 degrees, what's the angle? 150. Good. So you guys are getting it. Okay, so now don't take notes on this, just look with me. I'm going to make sure we understand what a real inscribed angle is, because I had secondary 3 kids this year not have the slightest clue, and it blew my mind. Is this an inscribed angle? Did it start on the outside of the circle? And it opened up on this arc, yeah? So because it started on the outside of the circle, yes, this is an inscribed angle.
So they always start on the outside then?
It has to start on the outside of the circle, an inscribed angle.
Okay.
So then look at this one. Is it an inscribed angle? Yeah, doesn't it start on the outside of the circle and it opens up on arc CD? Does everybody see that? So this one's also an inscribed angle. What about this? Yeah, didn't it start on the outside of the circle and open up on the arc? That arc. So it is an inscribed angle. Now here. No, look, my angle started right here. Did it start on the outside of the circle? No. This is not an inscribed angle. Is it a central angle? No, right? It didn't start at the center either. So there's no rule that goes with this one. Are we good? Well, you actually could learn one, but it would be in secondary 3. You'd learn how to do that. Okay, is this an inscribed angle? No, it didn't touch the outside of the circle. Are we all good? So the rule would not apply for this. And is this an inscribed angle? No, it's a central angle. So if this is 60 degrees, what's the arc? So it's 60 degrees. Good. So this one's still not an inscribed angle. It's a central angle. Okay. So here we go. It says, is the angle inscribed? If so, name the angle and the intercepted arc. So is this angle inscribed?
Yes.
Yeah, it starts on the outside, works its way out. So we would say yes. What is the inscribed angle? Angle C, right? Isn't that where the angle starts? And it opens up on the arc from here to here. Ding, 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 ding. So what's the arc it opens up on? Arc AB. Are we all comfortable with that? What if I threw in another point and said, there's a point B? Isn't it still arc AB? Yeah. Okay, awesome. All right, so do problems 1 through 4. So we know if we have an inscribed angle, it's half of the amount of its intercepted arc. So this angle will be half of the amount of this arc. So looking at this example, we're going to start at really basic. Don't take notes during this part, just look. Okay? This angle 20 is an inscribed angle. Yes. Does it open up on this arc?
Yes.
Yes. Okay? So this is 20, what's this?
40.
40. 2 times the angle is the arc, if it's inscribed. So we would say 40 degrees. Questions on that? So we did 2 times 20, makes sense, right? Okay. So once again, it says solve for x. So we're given an inscribed angle again, and this time we're finding an inscribed angle, and this time we're given the arc from here to here is 50. Well, if that's 50, what's the angle? 25. Because an inscribed angle is half the amount of the intercepted arc. We're all comfortable with the easy stuff, right? Okay. Okay, find x. So this is an inscribed angle. It starts on the outside. It's opening up on the arc from here to here.
40.
So you did 2 times that inscribed angle is equal to the arc, which is true, so that's 240 degrees. Questions on that? Okay, so now they're not going to be that easy, but that was a good start. So now we're going to be given a picture. It actually is that easy, it's just there's going to be a lot more going on in the picture. So I want you to look up here. You probably aren't going to be able to take very good notes during this, but watching is going to help you. Okay, so first of all, I just want to point out some couple things in this picture. There is a lot going on, but once we start to decipher it, it actually is really pretty simple. So first of all, I want you to look at this half of the circle. Now that's not actually a half circle. Did it go through the center? No, so you can't assume that that's 180 degrees. So don't do something like that. That's not a half circle. You can't assume that that's 180 degrees. So however though, so I'm going to erase that real quick. However, do we have a half circle right here? Yes. Okay, so we can assume for sure that that's 180 degrees. All right, so let's go through, and the first thing we're doing is finding x and y. So the first thing I'm going to do is say, what am I looking for? So isn't that angle x? Now, what is the arc that's an inscribed angle that opens up on this arc, correct? Do you see how it opens up on that arc? So if I knew that arc, couldn't I find that angle? Okay, so finding that arc is actually pretty easy. Isn't this a half circle?
180 minus 30.
So 180 minus 30 is 150 degrees. Does everybody see how I found that arc? So since that arc's 150 degrees, what will the angle be? Half of that, right? 75 degrees. So we found our first angle. Now next thing, I'm looking for y. Now y is also an inscribed angle. It's opening up on the arc from here to here. You've got to be really careful that you're opening up on the correct arc. Are we all good? Don't we know that arc? Well, that's 50. What's this? 25, because this is half of the amount of its intercepted arc. Questions on how to do either that one?
Alright, that's pretty easy.
Okay, next one. Every picture is a little different. Now, understand, there's many different ways to go about doing these problems. That's what's kind of interesting about them. Okay, so let's go through and solve for question marks. So first of all, I ask myself, what am I looking at? An inscribed angle, right? Now it opens up on the arc from here to here. So if I knew this purple arc from here to here, wouldn't I know that angle?
Yes.
Now, I have no way of seeing that right now. I have no way of knowing what that purple arc is. But we do have this given inscribed angle. Now I'm going to give you a hint. If you're given an inscribed angle, you're most likely going to use it. So we know that that inscribed angle opens up on the arc from here to here, correct? Ding, ding. So can we figure out this piece?
160.
Okay, so wouldn't it be 80 times 2? Okay, so from here to here is 160 degrees. Now I want to be pretty easy to find the purple. Isn't a full circle 360?
Yeah.
Ready, go. 360 minus 97 minus 160. Go. So I'm taking Brian's word for it. So this purple arc's 103 degrees. Okay, so if we know that that arc from here to here is 103 degrees, what will the inscribed angle be? How's that, right?
51.5.
51.5 degrees. Questions on that? Okay, awesome. Continuing, next one. So this one's a little bit trickier. So first of all, we need to find these two inscribed angles. So this inscribed angle opens up on the arc from here to here. I have no idea what that is, right?
No, but you could figure.
You could figure that one out. So why not? Why not? Let's do that one right here, right now. When we do 360 minus 30 minus 80.
Yes.
Okay, so go. Tell me what that is from here to here.
250.
What is it? I heard two things, so everybody try again. It's 250. So that's 250 degrees. So then what will that angle be?
Hold on.
Want to be half that?
25.
Are we all good though?
Yeah.
So that's 125 degrees. Okay, good? Now this next piece here is a little bit trickier. So we know that this angle opens up from here to here. That would be this, right? Do we have any idea how to split that 250 into just this piece?
You could do.
We can't just divide by 2. We don't know if it's split evenly.
Didn't you do 180 180 by 80?
You can do that.
No, because we don't have any half circles, and we can never assume we have a half circle.
Oh, point first one to see it has to be 200. Look at angle B.
Uh-huh.
Look at the other side and keep finding out.
Will be 200.
Because B is
Vertical angle. Kind of.
So there's many different ways we can think about this. So I'm going to show you one way you could think of this. If we're given this is 100 degrees, it opens up from here to here, correct?
Yes.
So that total amount will be 200. That whole yellow line is 200, correct? So 200 minus 80 would give us this from here to here, right? So 200 minus 80 is 120. Now, can't we find this piece? Okay, go. Find it. 360 minus 120 minus 80 minus 30.
30.
So from here to here is 130. Is everybody still good?
Yep.
Is anyone confused yet? Okay. So now we can go back to finding, first of all, we're looking at this. It opens up on the arc from here to here, right? Bing, bing. So what would the total arc be from there to there? 160. So then 160 divided by 2 is 80. Now, one other way of doing it was, if you have a four-sided figure, opposite angles should add up to be 180. So wouldn't that have been easier?
Yeah.
Okay, awesome. Do you see how there's many different ways to do it, though? So what do these two angles add up to be? Just curious. 180, good. But that doesn't work this way. You can't say those add up to be 180. Those aren't opposite. Are we all good with that? Okay. Last one, let's see. Last one I'll let you work. So we're finding question marks. So first of all, I say to myself, okay, so I know that's an inscribed angle. Well, if we know the arc, which opens up from here to here, we know the angle, right?
60.
So, well, how'd you get 60? Let's be careful before we go through this. So we don't have a half circle here, do we? No, but we do know this is 210. Okay, but then that's going to be a little tricky. Well, we do know this is 30, right? Doesn't that open up from here to here? So it'll be 30 times 2 is,
60.
this piece is 60, right?
That's what.
So now to find the leftover amount, won't you do 360 minus 210 minus 60?
Couldn't you take 15 out of 2 and get that angle? 90.
You could, yeah, that's another way. So I'm going to come back to that. That's another great way. Okay, so you found this to be what?
90.
90 degrees. Very good. So then this angle will be what? Isn't that the arc is opening up on, guys? 90 divided by 2.
45.
45 degrees. Now Justin was able to see, there's another way of doing this. Okay, so we found the answer. Justin was able to see, well, this angle opens up on this arc, right? So won't this angle be 105, right? So then couldn't you do, and then we wouldn't know 45, right? But then don't all three angles of a triangle add up to be 180? We would get 45. So do you see how there's many different ways of thinking about it? Are we all good? Okay. Do 5 through 8. So it says, It says solve for x. Look at our picture. With something like this, don't we have to set up a true statement and solve for x?
Yes.
If we set up a true statement, as long as it's a true one, then you'll be solving for x correctly. Now there's like so many different true statements. First of all, looking at this, we're not even dealing with inscribed angles because, I mean, we could technically be, but not really. This plus this is what? 180. Isn't that halfway around a circle? So a true statement would be to say x minus 2 plus 3x minus 2 is equal to 180 degrees. That's a true statement. Here's another one. X minus 2 plus 3x minus 2 plus 180 is equal to 360. Is that true? Okay, but I'm just going to use this one. Because that's easier. They will get the same answer as long as they're both true. I really had so many people doing like so many different ways, but they were all, you were getting it right because they were getting it all right because they were setting up true statements. And I actually, from teaching first hour to third hour, set up completely different true statements. It was interesting. Okay, so let's solve for x. So we combine like terms. We have 4x minus 4 is equal to 180. I combined like terms on the left. Then we would solve for x, so we'll have 4x is equal to 184, correct?
Yes.
I'm hoping that our algebra is good enough at this point where I can kind of skip like I am. Are we good?
Yeah.
Divide by 4. If you get lost, just say, wait, can you show me where you got that? Divide both sides by 4. Tell me.
46.
46 degrees. Now, x is 46 degrees. Now, I have people say, oh, so this piece is 46 degrees. Wrong. That's x. So, I mean, we're done, but just keep in mind that that would be 46 minus 2, right, everybody?
3 times 46.
And then 3 times 46 minus 2. Is everybody good with that? Okay, next problem. So it says solve for x. So let's set up a true statement. Now, there's like a million with this one. Okay, so let's think through this one. There's a million different true statements. But don't we have a half circle? So couldn't we figure out from here to here? 180 minus 60. That's 120 degrees. So a true statement would be to say, oh, isn't that an inscribed angle? So this times 2 is equal to this. Is that true? Are you paying attention or you're going to be lost?
Yes, sir.
This times 2 is equal to this. Couldn't I say this divided by 2 is equal to this? Okay? So I said 2 times the inscribed angle will equal its intercepted arc, which was 120. Are we all good with that? Yes?
Yeah.
Okay, sweet. So then I'd multiply it in. So I have, I wouldn't multiply it in, that's okay. 4x minus 8 is equal to 120. Are we all good?
Yes.
We'd add 8, so we have 4x is equal to 128. We divide by 4, you tell me. What's that?
32.
Anybody else get 32 degrees? Awesome. So then people said, oh, but Miss Christensen, that doesn't check out because that angle is not half that. Well, yeah, it is. That angle is not 32 degrees. X is 32 degrees, right? So we have to plug that in. What's 2 times 32? 64. 64 minus 4 is 60. Is that half of the arc? Yeah, so it checks out. Are we all good?
Okay, so we don't have to solve for the equation. We just
Right.
solve for x.
Right. The only reason I'm going, this is our answer for these. The only reason I'm going that far is to remind everybody that it's not our angle.
Yeah.
Okay.
Didn't you like work backwards and do 120 divided by 2 and then?
Yes, you would have got the same answer because think about it. If we did 120 divided by 2, couldn't we multiply both sides by 2? So we essentially mathematically end up with the same thing. But yeah, absolutely. That's totally fine. Okay, so let's do number 11. No, I want you to do number 11. Are you guys good to go?
Yeah.
Set up a true statement and solve for x. But it's got to be true. Ready, set, go. Here's some more examples of setting up true statements. So it says, find the measure of angle BCA. It reads in the order BCA. So you start at BCA. That's angle C. Does everybody understand that? Well, to be able to find that, first of all, that's an inscribed angle. Don't we need its intercepted arc?
Yes.
But we have no idea what the arc is because this is 3x minus 6. So to be able to find that arc, we need to solve for x first, right? So yep, let's set up a true statement and solve for x, then we'll continue by finishing this problem. So a true statement was 3x minus 6 plus 2x minus 4 is equal to 180. We combine like terms, we'll have 5x minus 10 is equal to 180. So we'll have 5x is equal to 190. So we have x is equal to, go, tell me, quick.
38.
38 degrees. Now remember, that's just x. So this arc will be 3 times 38 degrees minus 6. So what is that arc?
108.
108 degrees. So now if that's 108 degrees, will this angle be half of that amount? Which would be what?
54.
54 degrees. So we went through and found that angle. But we had to solve for x first, right?
Right.
Okay, couple more. So with this one, we've got to set up a true statement. First of all, this times 2 will be equal to this, right?
Yes.
Isn't that true?
Yes.
So 2 times 2x minus 1, 2 times an inscribed angle is equal to its intercepted arc. Or we could have done this divided by 2 equals this, right?
Yeah.
Either way, same thing. So we have 4x minus 2 is equal to 3x plus 18. We'll combine like terms, so I'm going to subtract 3x from both sides. So we have x minus 2 is equal to 18. Add 2, x is equal to 20, right? Now it says find the measure of angle ACB. So ACB, that's that angle, isn't it? So when we just plug in 20 and so that'll be 2 times 20 minus 1, 39 degrees. Okay. I have people not be able to set up a true statement for something like this. So look at it with me real quick. So we know that this times 2 is equal to the arc from here to here, right?
Yes.
So adding up that arc would be
X plus 3 plus 4.
right. So we would say a true statement would be to say 2 times that inscribed angle is equal to the intercepted arc. That intercepted arc is x plus 3 plus 4x plus 4. Combine like terms, so we would have 6x plus 8 because we distribute the 2 through. We would have is equal to 5x plus 7, right? And then we'll combine like terms. Subtract 5x from both sides. So we get x plus 8 is equal to 7. So we'd subtract 1, and you'd subtract 8, right? Now the people say, oh no, I must have done it wrong. But not true necessarily. If you're right, we can't have a negative angle, but if we plug in negative 1, are we ever going to have a negative angle here? No, right? So we're good. We can get negative x answers. Does that make sense? So it says find the measure of angle ADC. So ADC, that'd be that angle. So we have 3 times negative 1 plus 4. Negative 3 plus 4. 1 degree. So that angle is 1 degree. It's a heck of a small angle. I made that problem up, so that's why it didn't come out the best. I made a problem that's easy with algebra. Questions? So just curious, what would the arc be? 2 degrees, right? Good. Okay. This one, would you guys be able to set up a true statement, or do I need to do it? You're sure?
Dude, let's do this in front of it.
So, first of all, we know that this arc will be this angle times 2, right? So this arc is 2 times x plus 25, am I correct? So then wouldn't this plus this equal 180? Are we good? I'm not going to continue then. Finish the worksheet.